Well, we're on the last two sections of chapter 6, and we're going to be talking about blood typing and transfusions first. So, what things do you need to know about donating blood? Well, donating blood is safe. It's an incredibly sterile procedure. You donate about a pint of blood, and those blood cells that are donated can be replaced in just a few hours, or you'll replace the plasma in a few hours, and the cells are replaced within a few weeks. Some people feel a little bit dizzy just because of a reduced volume of blood, but if you sit down, eat a snack, drink some water, you'll be just fine. Once the blood is donated, you get tested for syphilis, HIV, antibodies, and hepatitis. And if any of those come up positive, you get a notification that you have that. But it also helps prevent someone getting a blood transfusion that might give them one of those diseases. And then blood transfusions can save a lot of lives. So, a couple of things that they ask people not to do when they shouldn't give blood. If you've had hepatitis or malaria, been treated for syphilis or gonorrhea in the last 12 months, or at risk for having HIV or AIDS. But otherwise, most people are totally good to donate blood. So when we start donating, I remember my granddad, he was in World War II, and he was the doctor, well, he was called Doc, and he was the medic on a submarine during World War II. And he said they knew that they could give transfusions and save lives, but what they didn't know was why sometimes it killed people and sometimes it saved them. And they just thought there's something in the bloodstream we just don't know about. And sure enough, it turns out that there was. Blood comes in different types. You can have A, B, AB, or O. And so we need some terms in order to understand this. An antigen is a foreign substance. This is something that your body doesn't recognize and your immune system wigs out about. And it produces an antibody. This is a protein that's made to respond to that foreign thing, that antigen. And it's got a specific shape that will then attach to the antigen and immobilize it. During a blood transfusion, we're going to take the blood from one person and put it into another person. And so when we start looking at blood type, we're looking for the presence or absence of particular antigens, A and B. If you have type A blood, you have an A protein that hangs off your blood cells. If you have type B blood, you have a B protein hanging off the blood cells. If you have O, you don't have either of those. So then we can look and see what antibodies are present in your blood. Antibodies are only present for those antigens lacking on the cells because these proteins are recognized and bind the protein they are named after. So if you have type A blood, do you see how you have those A antigens right there? But if you were to be given B blood, it has a different shape on the blood cells. And so these B antibodies would be attacking it. So someone with type A has A proteins on the surface or antigens, and it has antibodies that'll fight off type B blood. So, how do you remember what each blood type means? Blood types are named after the protein antigens that are present on the surface of the red blood cells, except for type O, which doesn't have any of them. Blood types only have antibodies to their antigens, and they do not have on the surface of their red blood cells. For example, someone with type A blood has A proteins on the red blood cells, but B antibodies. So what can you say about someone with type AB blood? Well, they would have both A and B proteins on the surface of their red blood cells and no antibodies in their blood. So let's look. If you have type A, you have the A proteins or antigens, and you can fight off B antibodies. If you're type B blood, you have the B protein and you have antibodies for type A. See how it's got that hook on it that would fit just right on those antigens? If you have type AB blood, you have both proteins, both antigens, and no antibodies. If you have type O blood, you have absolutely no proteins on your red blood cells, but you have antibodies for both A and B. So, how can you determine if blood types are compatible for a blood transfusion? First, you consider the antigens found on the blood transfusion donor's red blood cells. Then consider the antibodies that they have. If the antibodies in the recipient's blood can recognize the antigens on the donor's red blood cells, then the blood will agglutinate or clump and cause rejection. So, for example, if you look, pardon me, and you take A blood and put it into an A person, they don't have antibodies for A, so it's just fine. Pardon me. But if you put A blood into a B person, the antibodies will cause it to clump together, and it's bad news bears. So we'll talk about testing in the lab, but can a person with type O blood accept a blood with type A without agglutination occurring? No. They will have antibodies for A. Bad news bears. AB blood can accept more blood types than other people because they have no antibodies. They have all the antigens. Everything looks normal to them. So O, A, and B can all be put into their bloodstream. They're called a universal acceptor. But type O blood has no antibodies, or I'm sorry, antigens, which means that you can put it in anybody's bloodstream and there's nothing for the blood to react to. So they are universal donors. The Rh factor was found by studying rhesus monkeys. That's why it's called the rhesus factor. We do have to take into account if you have the factor, you're considered positive. If you don't, you're negative. People with the Rh factor will accept Rh positive and negative blood. People with Rh negative blood must get Rh negative blood donated to them. This can cause a problem with a mother. If she is positive and the baby is negative, it's not a problem. But if she is negative and the baby is positive, then sometimes there will be a reaction to the baby. During pregnancy, if mom is negative, dad is positive, it's possible for the baby to end up being positive. Some of the Rh blood leaks from the fetus into the mother during birth, causing the mother to make those antibodies. This can be a problem if the mother later has a second fetus that is Rh positive, because now she has the antibodies that leak across the placenta and attack the fetus. It's hemolytic disease, and it can even lead to death. My uncle had this problem when he was born, although they were able to save him. Nowadays, if they know that the mom is negative and the baby could be positive, she takes a medication to prevent this from happening. And so here's a visualization of that occurring where we're seeing mom's antibodies actually attacking the baby. We can prevent this by giving the mom an injection of anti-Rh antibodies no later than 72 hours after giving birth to an Rh positive baby. They attack the fetal red blood cells of the mother before the mother's immune system can make the antibodies. It's repeated every time the mom has a baby. The last section is just talking about homeostasis, and we can think about how the bloodstream is so good at helping us maintain homeostasis. We can affect where the blood goes in the body. It helps transport waste. It helps get rid of carbon dioxide, helps us get blood cleaned in the kidneys. It also helps us direct thermoregulation. It helps with the hormones being transported through the body, getting rid of the gases. In the lymphatic system, it helps with returning fluid into the bloodstream. It helps with the immune system. It helps produce the red bone, or the bone marrow produces blood cells. It helps blood moving through the heart and the blood vessels, allowing things to be delivered to the muscles. The bloodstream is an incredibly important part of the body. And so in conclusion, this last section was talking about blood typing with A, B, O, and your Rh factors, which is negative and positive, and homeostasis. Thank you so much.